right, good afternoon everyone and welcome to our session of deploying a global robot workforce for industrial inspections. My name is David Bolt. I'm a solutions architect from AWS, and today I have with me two amazing people from ANYbotics joining us today.
Hi, my name is Audrey. I'm leading the field engineering team at ANYbotics. I've been at ANYbotics for 4 years, traveling around the globe to help our customers install our robots in their facilities.
And I'm Robert McKenzie, CTO Solutions of ANYbotics with the company for just over 3 years. A little bit, not as long as Audrey, but in that time I've been able to see the robotic technology in ANYbotics transform from something still impressive a few years ago, but now into a full-fledged product that we're really bringing to market around the world. I think maybe before we jump into the full content, I don't know about you, but sometimes we hit this afternoon dip. So just a reminder, if you want to do a bit of box breathing, I hear that's a thing at AWS as well, right? 4 in, 4 out. Or even if you want to do a bit of a stretch, don't worry about it. We have plenty of time. I'm going to do one as well, just to wake ourselves up so that we're fully engaged for the presentation of today.
Well, there's nothing more to add, right? Then we're going to get things started. So first, we'll have a look at the agenda. I will basically set up the stage, and I will introduce the term, what is cloud robotics? What do we mean by cloud robotics? Then Robert will take over and explain the story of ANYbotics and their journey of connected robots. Then we'll have a look at the solutions architecture, which is currently used, followed by, which is at least for me, the most anticipated part of this session. We will have a live demonstration of ANYmal, which is the robot from ANYbotics, live on stage, followed by you experiencing or seeing what it means having ANYmal in operation at customer side of ANYbotics, and then we will close off with our final remarks. So what is cloud robotics? Cloud robotics is a field in robotics that leverages cloud computing to enhance the capabilities of robots. Because there's more to modern robot than meets the eye. Physical devices are dependent on systems that train them and provide intelligence. And today, these machines, as you will experience live, can achieve new levels of automation that goes beyond what rigid programming models could enable. They learn from their own behavior and make dynamic decisions based on the data they gather from the environment in which they operate in. So for robot manufacturers like ANYbotics, their data and application strategy dictates whether they're able to build mature solutions from day one, innovate on behalf of their customers, and achieve operational excellence. As part of this strategy, robots expand computational tasks and data storage to the cloud. They then can rely on a secure and highly available infrastructure, and robot manufacturers then can build their solutions in the cloud quickly and reliable. For example, interfaces for bidirectional communication, monitoring dashboards, or for tasks like distributing software packages. On top, they can also take advantage of the elasticity of the cloud, which is fundamental for the concept of robot as a service, or short RaaS. RaaS is a business model that allows access to robots on a subscription or pay-as-you-go basis instead of selling the robot as a one-time product. Then RaaS providers like ANYbotics can take care of the maintenance, software updates, and can cover any other operational aspects. This allows basically their customers access to robots and robotic services without investing significantly upfront in hardware. So with that elasticity in mind, and by deploying to the cloud, RaaS providers and robot manufacturers can then adapt to the fluctuation number of robots, for example, when the number of subscription changes, and provision the resources when needed. All without investing in on-premise hardware, which might be underutilized during periods of lower demand. And since we're talking about a global workforce, especially scaling up is essential to ensure the future readiness for a growing number of robots and to meet the demand for more complex task-solving applications which will come up in the future. Also, the pay-as-you-go principle for RaaS customers also applies to RaaS providers and robot manufacturers in the cloud. They only pay for the resources they need, and by effectively managing the application, they can operate in a cost-effective manner. So the two aspects, scaling depending on customer demand, and only using resources they need, build the foundation for RaaS. And embracing cloud robotics allows then robot manufacturers to fully benefit from automation. They can rely on a secure and highly available cloud infrastructure to reduce downtime of their robotic systems and to ensure a continuous operation. And also, by effectively managing their application and also lowering resources when less in demand, they can operate the application cost effectively. This is it from me. This is the introduction. I'm going to hand over now to Robert, who's going to tell the story of ANYbotics.
So thank you, David. So I'm going to dive deeper into cloud and robotics from an ANYbotics perspective, especially in the context of our partnership with AWS. So ANYbotics is a Swiss-based company, and we have over 250 workers, or team members as you were, and over 140 of them are human. If you do the math, this means that we've already, in the past year or so, deployed over 100 robots globally into operation and testing. That number is going to grow a lot by next year, as you'll hear later on in the presentation as well. And here we see, at least on screen, one of the stars of the show. You'll see later on in the live demonstration. And we really look at ANYmal really as a coworker. Why? Because it's built to complete jobs. And within the context of reInvent, I think this combines sort of in one picture some very exciting topics where we have AI, we have cloud, and robotics converging all on this slide and in the robotic system that we create. So speaking about what we do, we are not a robotics manufacturer. We're not a hardware company. We are a full solution robotics provider, meaning that when we build our robots and it's shipped to customers and they take it out of the box and push a button, the robot activates and comes with the capabilities of solving end-to-end problems out of the box. This is an overview of some of the capabilities. For example, on the far side, you see here stair climbing with AI agility. We're not going to go into detail today, but ANYmal, through reinforcement learning, is able to fundamentally learn how to teach itself how to walk. So including simulation, it has some no prior information, and then step-by-step to trial and error, and many millions of iterations. Then it turns into the agile system that you'll briefly see today. Another key characteristic of ANYmal is that it's able to understand and perform in 3D environments, so large-scale, multi-floor. So this is also one great advantage of having a quadruped as well, instead of something like a wheeled robot that may be also just confined to one space or one floor and can't overcome certain obstacles. Then, on the sensor set, we'll go deeper a bit later on, but ANYmal has a full set of sort of superhuman sensors, like seeing temperature, something that we humans can't do. And to make all this work and make sure the data is flowing so that we obtain everything that we want from these solutions when the robots are inspecting industrial spaces, then we, of course, integrate with the world's leaders. The DNA of the company has been working on robotics for quite some time, as you can see on the slide, all the way back from 2009 with the first quadruped. And on the far right, you can also see that it's only very recently that we've gone into commercial deployment, sort of the very, very end of 2021. So the red robot you see here today is for normal industrial environments. And we'll also at times make reference to the one that's currently colored gray on the slide. That's our ANYmal X robot. The robot here stands for explosion-proof, meaning that it's not only built but also certified to not cause explosions. And thus, this robot can enter and operate into different types of hazardous environments, sort of zone 1, gaseous, oil and gas, chemical industries, And this is the only such quadruped in the world with this level of certification. So from early research all the way to the right-hand side of the timescale, I think you'll see, and part of the presentation today is make it very, very clear that we are an industrial product of very high quality and a very high standard. And we're on a mission. Our company mission is to create a workforce of autonomous robots. And of course, on that mission, we're also on a journey with AWS. In the beginning, our services were then hosted on AWS, but we're slowly adding a lot more capabilities with AWS as a partner as we continue on our path towards true autonomy. So one is collecting data from around the globe to make sure that we understand and monitor the health of our coworkers when they're in the field and deploy globally. And as we continue, we'll optimize integration. We'll hear more later on about some of our plans when specific customers who are already using AWS in various industries, how we can move closer to a tighter integration with them, as well as then working with partners in the AWS network to find and curate certain or specific solutions for inspection. So really for end user application as we augment the capabilities of what the robot is able to do over time. So this is all about enabling the future. And it's going to be a bright future. And one of the reasons why it's all very exciting is that we use multiple forms of machine learning, reinforcement learning, and AI to make ANYmal all come to life and support all of these efforts on this journey or on our mission. And in day-to-day life, when there's a lot of challenges, when things don't always go right in our R&D environment, or as we're deploying and we're learning from going in the real world, I like to remind myself that we are walking where there are no paths. Sometimes this feels akin to, although I wasn't alive back then, what it may have felt like 130 years ago when the first automobiles were starting to enter the roads when there were really no roads as we know them today. So there was not really a recipe on how you would do that back then, and right now we feel every day that there's no real clear recipe on how you bring such an intelligent or like autonomous system into our daily lives, starting with industries, but of course, over time, these robots will more and more amongst us. And part of this idea of this autonomous workforce is that very soon, or actually even right now as we're deploying the robots, we already have robots that are doing independent tasks, completing independent jobs next to human coworkers who are also then completing their version of their independent jobs. And we're evolving that as our robot and ANYmal are also then collaborating with humans. And that will continue to evolve when we have robots then collaborating with robots, which is something that we see more in our labs, not yet in our real world. So to speak about some of these challenges along the way, let's dive into a few details. Because we don't just want to have the challenges, we want to solve them, and we're solving quite a number of them with AWS. Quite obviously, right, when you deploy a global fleet, we don't just ship and say goodbye. We also then want to stay in contact and service that fleet. Part of that is also the need to collect and synthesize the growing number of data that we're receiving from the fleet. In our paradigm, in many cases, it's the customers. The data belongs to them first and foremost. But there's a certain type of data that we also can access to, and to make sure that it's all being structured and collected is certainly a challenge for a young company. And I think a common challenge that we have with AWS is that all three topics, not just one of them, but all three of robotics, cloud, and AI sometimes always aren't accepted, right? I think maybe now along this journey, the cloud seems a bit more accepted. But of course, you rewind a few years ago, there were still people that said, no, I don't want my data in the cloud. Now you add artificial intelligence onto that, and you add sort of a robotic system that's still proving itself. You have sort of a culmination of challenges in terms of creating trust. And certainly one part of making sure we can create that trust is working with companies like AWS, who then really can build that trust together with us. Autonomy, right? One aspect of autonomy, which is a little bit different than some other cloud applications, is that our robots are not always connected to the internet. In fact, there are days, weeks, or even longer periods of time where they have no internet connectivity meaning that we need to navigate the known and unknown. So in this picture, you see certain examples where the robot sort of knows its area, and it knows there's connectivity in the area. But then there are other, all combinations, in fact, of moving into other areas that it sort of knows, but maybe no connectivity, or there's unknown areas that have connectivity, et cetera, all the way to the void where you have everything. Now, we're not going to go through all those combinations, because the point is that we should never lose a robot. In fact, the robot should never lose itself, so that the ultimate goal is achieved of never losing the important data that the robots have collected on their inspection missions. The next challenge is our human world. So it's great. I mean, I think the world is built for us. And I think that's sort of very beneficial for us in the way it should stay in many ways. But of course, then creating a robot that can understand and navigate that world, that 3D world, is of course a challenge. And even on this slide, if you can do so, and you kind of stare at those stairs for a while, you can sort of see that they're a bit transparent, like there's no background to the stairs. And sometimes the foreground and background begin to sort of swim or become confused. And not only that, but you can sort of see a grid pattern on top of the stairs. So sometimes even for human eyes, these stairs can seem somehow very almost transparent, translucent. And it's also the same for robotics. So we've done a lot of work to basically almost bend the rules of physics so that our sensors are able to recognize these types of obstacles that for us are very, very normal. We can navigate them very, very easily. But for a robotic system, this is still quite novel. And now coming to the challenge that ultimately leads to why we have created a company out of this, and one that's growing quite rapidly. And these are problems that have existed for a while in the various industries of the world. One is that they rely on human presence, and what has become much more acute in recent years, and will continue to do so, according to trends, is the missing workforce. So the older generation is slowly going into retirement. There's claims the younger generation doesn't want to do this type of work. Why? Because it's dangerous in many cases, it's dull, it's routine, dusty, dirty. And these are just not conditions where people really like to work. Just for all of human history, there really hasn't been another alternative. Right? So underground in a mine, you're not sure if it's about to collapse or not. So, sorry, Bob, can you go check it out? There was no other way of navigating that for a while. And now we're crossing the line where we have another option with an autonomous robotic system. And then when you combine humans, even if they're doing a good job, there's probably no human that every day at the exact same time at 12 o'clock and then 12:37 and then 10 seconds later is going to collect the exact same data at the same points to such a certain quality. And then if you combine that amount of precision to a human working in a dull, dangerous, and dusty environment, stressful environment, that human is also prone to mistakes. And that can lead to injuries, but it also leads to not always an optimal performance on the job. And then human presence is actually the leading cause of most industrial accidents. Now, all that adds up to either lack of more uptime and productivity or increased downtime in many of the facilities. And things are changing, as they should, because a lot of people are looking for solutions, as are we. And this is always evolving, and something that's really not part of what we do is this first level of basic automation. And as we know, people have been installing sensors in industries for a long time, and then actuators that can be activated, and that's fantastic. They can only address a certain amount of a problem because you can't have sensors everywhere. That doesn't scale very well. And of course, if you have a sensor here and a sensor there, then what are you monitoring in between if there's a problem? And so there's no one way of solving that level of automation in all places just with this method. So, especially in recent years, the world has then evolved to assisted operation. I think one very clear picture we now take for granted is this idea of a drone. This is a great tool because it extends the human capability, right? You can do more with this. You can see things from above, flying on top of things, as you know from the videos. But even this is just a one-to-one relationship. So you still need one human to control one drone or one tool to assist in the operation. And where we want to go is on this next level of the autonomous industry. So that's what we are creating, or one of the actors, leading actors creating that. So this has also two sides in all of these levels. On the measure, on the act side, Part of our future will be then, and then maybe a common question later on is, you want to put an arm on the robot? Of course we do. But in many cases, this is still an unsolved problem in such a complicated system to have a really performant arm on top of a robot. When we can do this, this is how then algorithms, data platforms, the digital world then can touch the world again and act with the world. For now, our emphasis on the measure side with the mobile sensing platform of ANYmal to collect very valuable data, and through the behavior of ANYmal to make sure that the data we collect is of highest quality so we can feed it into a data platform that we don't build. So as a company, we're providing this really intelligent system that can change its own behavior in missions, in complicated situations to ensure data quality. Then it flows into something greater, which is why integration is a key part of our strategy, which I'll mention a bit later. I think this is also important because I think sometimes people look at ANYbotics and they just automatically assume, oh, you must be building a robotic system and you're building this all-encompassing software on top. And I think there are in themselves billion-dollar companies that are just trying to build these data platforms. So we're not trying to do both. So to capture this data, ANYmal has quite a set of sensors that are all integrated inside the robotic platform. So again, when you buy the robot, it already comes with all of this. You don't need to add more on top. You can, if you want a specific sensor set, but you don't have to. And you'll see some of these today. So it's using the LiDAR to scan the environment and understand generally the geography of a room, 2 wide-angle cameras, 6 depth cameras, zoom camera, ultrasonic microphone, and a thermal camera on top. Right? And then once we collect this data, obviously AWS is a key partner in helping us then transfer that data over the platforms from the robot into the customer systems. Now, some of the jobs that the robot can do on ANYmal are what you can see on screen. You'll see some of these demonstrated in a live demo today. Now, I'm not going to go into all details. I think one that maybe won't be so apparent today is the ability to also create and update digital models on the far right-hand side. And one of the exciting things why our customers love this is that for many years they say, yeah, we have a data platform and digital twin, that model is always out of date. And we already see right now more and more customers adopting and using and actually being able to quantify return on investment from this because they finally have a system that can very reliably walk around the facility, do routine inspections, and deliver exactly that data that rejuvenates, that always keeps their digital twin up to date. And if it's up to date, then they can begin to derive other actions from that. Part of the solution set is our human-robot interface, if you would. That's we call it the Workforce Suite. That was used by Audrey today when she was then training ANYmal on his mission, or its mission for the stage today. It comes in various forms. It's a web-based application for both normal PC and tablets. In fact, I can also run it on any device, right? So my cell phone, I could wake up ANYmal right now. And this is also used for the full deployment of the robot. So if I want to actually train ANYmal on mission, all I need is this, and it can accompany me on its training day, and I can make sure that it knows its path and all its inspection goals. Once it has it in the system, it knows the mission, and it can repeat that mission day in, day out for as long as the robot system remains healthy. On the integration side, as I mentioned before, to the data platforms, is we have our robot server API, we refer to as ANYmal API, which enables any third-party system or any compatible third-party system to then send command and control actions to the robot. So the simplest one would just be to trigger start mission, and then independently then stands up, walks around, does the mission, collects the data, and then back to the API, it sends the data into that third-party system. And again, this is so the robot represents a unique collection system of a certain type of data that was, in many cases, not otherwise accessible through the inspections at industrial sites. And then in this data system, of course, it will be combined and post-processed with various up and downstream data sources running on the entire facility. Now, a little bit under the hood, speaking of architecture, I think at AWS conferences, it's both encouraged and very wanted and excited to speak about architecture. So we have some principles that I've alluded to as well. So the full autonomy is definitely core to make sure that such a complex system is able to work. And this goes hand in hand with the one sort of below that, with the idea that we have to account for no connectivity. Why? Because we need an architecture such that the robot is able to make decisions on its missions. So if something happens, if a path is blocked, then the robot can find an alternative path and complete its mission. If it's trying to capture a gauge, and right now the lighting is blinding and it somehow can't see the number, then they can step to the side, change its angle, and do that in mission without the human operator telling it that it has to do this. Again, why? Because it knows its mission is to collect highest quality data. Such a complex architecture, of course, will eventually change over time. Our daily life is changed, especially in our company. That's why modularity is a very important part of what we need to build. So we need to be able to add on aspects that we never anticipated 1 or 2 years ago to a robotic system and its underlying architecture. API I've already mentioned words about, because integration is a core aspect of making sure that the data flows and we're not just trapping everything on the robot, and safe and secure connectivity. So obviously with such a system being deployed to the world's most critical industries, all of the customers are correctly concerned about cybersecurity and secure data. Therefore, that is a key pillar of what we built into the system from day one. Now, the workflow from a sort of a customer's perspective, what happens? So if I'm a customer, then I want a robotic system. I place the order, and we're very, very thankful for that. And then we can bring up our robot as a service instance through AWS. And this contains a set of services in this infrastructure, so containerized, that we can then deploy on-premise, or the customer then connect to our infrastructure in the cloud. And this contains then the elements I mentioned before, the API, the main GUI, but also simulation environment to allow for mission testing, as well as the data synchronization system to make sure the information is flowing between the robot and the customer system. Then once the robot's on site, an operator, like Audrey was this morning, is able to interact with the workforce application and then train the robot. This creates the mission understanding, so it's at a 3D coordinates, as well as an entire mission logic. And once you have that, then this can actually be transferred to any one or multiple numbers of animals that would exist in your fleet as a customer. In addition, this is the moment when, on the customer side, then you can do the integration, connect the API to your data platform, and that would give you the ability of being able to, from the third-party system, then trigger these missions in a scheduled way. And then once you've done that, then bang, you have your new trained coworker ready to, day in, day out, stand up multiple times a day and do one or multiple types of routine inspections inside your application, inside of your environment. The robot then is able to also report a certain set of data back to us into our infrastructure on error reporting, on telemetry. So this is sort of the fundamental sort of analytics of the robot in terms of the number of steps it takes, CPU usage, battery power and degradation over time, as well as, of course, the software distribution to make sure that we're constantly deploying updates to the fleet. And then on the customer side, they decide when they want to consume those updates and then upgrade the robotic system. So this is where I'll take a small break. And a question to you, David, if you can maybe explain aspects of our solution architecture from an AWS perspective.
Sure. Thank you, Robert. So as Robert already mentioned, ANYbotics has a quite unique requirement from their customers, right? So some of their customers require them to have the application installed on site. So by choosing a container-based approach, they can then standardize the application and use similar tooling across all installations. As well as they can then deploy on all sites with very little variation and keep the management overhead low because all applications use the same structure. On AWS, ANYbotics scales and operates their application using Amazon EKS running on EC2 instances. Amazon EKS is our managed Kubernetes service to run Kubernetes in the AWS cloud, and it scales and manages the Kubernetes controller plane nodes, which are responsible for scheduling the containers and managing the overall application availability. So that means for ANYbotics, instead of managing the hardware and managing the Kubernetes control plane, they can spend their time basically developing their robotics solution. On top, EKS offers high availability by distributing containers across multiple availability zones. This is crucial for ANYbotics, because as you heard, the robot might not have connectivity at all times. But when it does, it needs a secure and reliable endpoint to connect to, upload the latest data, and possibly retrieve the latest mission data. But also their customers benefit from this kind of architecture, because at any point in time, their customers can connect to the endpoint, pull in the latest data from the customer side, possibly update their digital twin, and also update missions or create new missions for ANYmal itself. Another aspect what Robert mentioned is that ANYmal is deployed at industrial sites worldwide. So by leveraging the global footprint of AWS, ANYbotics can bring the application closer to the robot, which reduces latency and then translates into improved performance for their customers as well. So what it means, they can reuse this architecture and structure for basically several robots and different customers, and can also scale the solution. Because EKS can also automatically provision new resources, for example, when traffic increases, and equally important, also scale down when there's less demand. For example, their customers use the application less frequently. And this allowed ANYbotics, as Robert already briefly mentioned, starting in 2001, basically introducing the first industrial solution, industrial robot to their customers, to now have over 100 robots deployed worldwide. So what it means by the end, that AWS takes care of the undifferentiated heavy lifting of the application, while ANYbotics can set their focus to generate value for their customers and build the application itself. But since this is only the current architecture, Robert, how does the future look like?
Yeah. So I think the one good word was heavy lifting. So as we continue to go on this path, I mentioned from hosting to robot health, as we go towards more autonomy, we are actively investigating not building everything ourselves more and more. So phase 2, and the next step, we would also consider using more specific managed services from AWS. And also this is driven by a customer need. So for example, if you're a customer and you're already an AWS customer and you're using authentication services, so incognito, right? Then why does that need to be part of our deployments? Why does the customer need to sort of indirectly pay for 2 types of authentication services? So this is where we'll be optimizing our deployment model in the cloud to make sure that when we find and we have identified some managed services from AWS that can do a better job at scale than our current solutions, we definitely want those inside of our overall package that we make available to the customer. Last but not least, we're hearing as we deploy more and more, customers that say, you know what, great, we're convinced we want more robots, but we are also an AWS customer, we want a tighter integration. So we're learning the aspects of what that means to the point where we can package our services differently, so that we're only giving the customer the specific services that ANYbotics provides, and then we have a stronger integration directly into the pre-existing services on the customer side through AWS, so that we can then, with that mixed set of services, deploy so the missions of the robot successfully and continually. Again, because we want to go from this 100 of robots that we mentioned today to a few thousands around the globe in a few years, 1 or 2 years. So it's an ambitious goal, but of course, I think we're approaching the moment that hopefully many of you have been long waiting for, because now it's really time to meet the star of the show. ANYmal is going to perform his live demo, and for that, I would like to pass off for the rest of the presentation the word to Audrey.
Thank you. All right. Thank you, Robert. Thank you, David. It's now my honor to introduce the real star of the show, our robot coworker, ANYmal. Let me wake him up. And before ANYmal joins me on stage, I will explain what we're about to see. So ANYmal will be running a fully autonomous mission. As we've mentioned before, we came early this morning and trained the robot to be able to climb these stairs and recognize this environment in order to be able to execute a few inspection tasks on stage. So as the robot executes this autonomous mission, I will be showing you what the robot sees and hears. We'll go through a few different inspection tasks, as I've mentioned. We'll take a look at the numbers that are indicated on our timer left. We'll check the thermal signature of Robert and David, and finally we'll detect the frequency of a dog whistle. So I will be starting our autonomous mission. I will stop controlling the robot, and I'll keep my interventions to a minimum, just briefly explaining what's happening, because you'll see the robot is a little bit loud. Here we go. So as mentioned, I'm giving over full control, and the robot is just autonomously recognizing the environment and executing the mission that has been trained this morning. So as we mentioned, our first task is going to be to read our counter. And again, this is pre-recorded. I don't have that much time left to talk to you, but this is what the robot was seeing this morning. You can see here the intelligent on top of the inspection capabilities. So the robot is able to read the numbers that are displayed. Next, we've had a quick thermal signature, quick COVID check, nobody's sick. All good. And we'll move to the other side of the stage in order to do our audio frequency detection. Happens that we have an obstacle in the way. The robot is able to avoid that. And again, so this is the recording frequency here. We can see that our dog whistle is around 7,000 hertz. And it can happen that ANYmal encounters obstacles in its ways that were unknown, unplanned, and it is able to react to that and to adapt its plan, right? So we'll see there's a timeout, but by the time it realizes I'm not going to move, it's going to replan the path that it will take around me. Great, so sending ANYmal back to sleep.
How about a round of applause for ANYmal for the 3-minute open?
Before we continue. Great, thank you, ANYmal. So you've seen some of ANYmal's capacities right now. There are more. ANYmal can be equipped with a variety of additional payloads in order to unlock additional tasks and inspections for fulfilling various duties at our customer sites. Here you have, as an example, our gas sensing payload, which enables ANYmal to detect hydrocarbon and toxic gases and provide real-time feedback on these concentrations. So you can see here these bubbles, colored bubbles, right? The green bubble would indicate that everything is fine. Yellow bubble, that's the warning threshold, and the red bubble would be the critical one. And the more solid the bubble, the higher the confidence in that measurement. Another thing that you haven't seen in the live demo is how ANYmal collects and uploads the data to our servers. So we've mentioned multiple times that these robots are our co-workers, and therefore we take full responsibility for their health and for ensuring that they are performing at full capacity. And these dashboards, with all the mission data that ANYmal is continuously collecting, are allowing us to have this overview and to ensure the health of our robotics fleet, as well as also enabling our customers to have this overview of their robots. Now, we provide value to our customers by giving them access to these critical insights into their assets. And we have a growing numbers of ANYmals deployed globally that are collecting these critical insights. And I want to highlight two of these coworkers that have been providing value. So today you've seen ANYmal in action. Last year, 10 leading global companies have had the opportunity to join our early adopter program to test ANYmal X. So as mentioned, ANYmal X is the robot version that is certified to operate in potentially explosive environments. And so one of these impact stories that we've worked on was BASF. So BASF is the world's largest integrated chemical complex. The site at which we deployed ANYmal X is really, really huge. It's its own city, really. It has 3 train stations, more than 10,000 employees. And so after 20 days of intensive testing of our robot there, they were able to confirm that the robot is ready to operate in this Zone 1 environment. Another one of our robot workers is working for Grace Chemicals, and I want to quote their testimonials that said that the extrapolation of the savings over a year for one plant shows about a 1.5% increase in production uptime. And this is a significant contribution directly attributable to ANYmal. So we're particularly proud of this specific ANYmal that has been operating now for a year and a half, running 5 missions a week, and collecting all this critical data of different types, thermal data, visual data, acoustic data, in order to provide this business impact. And beyond these 2 examples, there are many areas in which ANYmal can provide really this value. And now that we are globally deploying more and more robots, we're able to evaluate this impact with our customers. And you can see a few examples here, but so one ANYmal deployed for 1 year on a facility can bring an impact within a range of a few $100,000 to almost $3 million. And a big part of this impact is our partnership with AWS, that as we deploy our robots, helps us structure this very important data that we collect. Now, looking to the future, we've heard that 2024 is planned to be a very exciting year. We're planning to deploy more than 200 ANYmals worldwide. This is what my team does, right? So while I'm talking to you here, my team is in France and Japan and Norway, helping our customers, setting up ANYmals on their side, connecting them, and starting to get this data. So this also means that we will expand our collaboration with AWS in order to make our data platform integration more flexible and really be ready to collect all of that data from thousands of robot missions worldwide. I hope this helps giving you an idea of the potential of our global robot workforce. Thank you very much. Would be happy to talk to you more. I think we're going to do a Q&A. After that, visit our socials. We'll also be happy to have you come over at our booth in the village at the expo at the Venetian. And please fill in the survey so that we can have some feedback.